What's up YouTube, Dervidor Welder here, coming at you with another video. I will be making a video sometime of a rig tour of the 350 here. As you can see, a lot has happened to it. It's really a different truck than it was this time last year when I made the original rig tour video. I've been using it for over a year now as my primary truck, so lots happened to it. It's got a lot of upgrades. It's pretty much at a really good point where I can back off and say, all right, this truck is where I want it. So today we're going to be talking about something different. So today we're going to be talking about my acquisition of two Miller Big 50 diesel welders. Now, I got these in a trade deal. I fixed a guy's excavator for two of these. One of them is completely disassembled and pretty much useless. This one is mostly assembled and I was able to put back together and get running. So there's not a lot of videos on how to make these things work and really to help you understand how they work. So I'm going to go over what I did to fix it and how this machine works from the moment you turn it to start it to running and everything like that. So here we go. So I was fortunate that I had this Miller Big 50 here for parts. Somebody had disassembled it. So I got two. This one's on the trailer. Obviously the trailer isn't very usable right now, but I will utilize this trailer for my Miller Big 50 for the running one. This one will be taken off once I'm done, and the other one's up and running exactly how I want to. The running one will be put on here because I like this little trailer minus the mobile home wheels and axle. That'll probably change. The eventual plan for this will be this will become a light rig, trailer rig thing, if that's even the right word. There'll be boxes on either side. Up here, oxygen and acetylene. Oxygen on one side, acetylene on the other. Big bottles, no little ones. This will be a 300 oxygen and a 145 acetylene. And if I don't add a air compressor to the Big 50 by doing a York air compressor kit or something like that, I will be putting a wheelbarrow air compressor right here across the front. This trailer, being that it's made out of a very heavy C channel, and the axle looks like it's pretty steady, so I'm pretty sure this trailer can more than handle it. The idea will be it'll be a trailerable arc gouging rig is kind of the idea for doing really heavy stuff that is very strenuous, that I really don't want to put that strenuous stretch on my Bobcat or my SA200, which I've done a lot of gouging, a lot more gouging with the Bobcat than I probably should have, and I really pushed that SA200 probably more than I should have. The Big 50 will take some of that load away from those machines because the Big 50 was built from the ground up with that kind of work in mind. So this Miller Big 50 I got here, it's the diesel, so it has the Continental TMD 27 four-cylinder diesel engine. I don't know exactly what year this is, but I'm assuming 80s, maybe early 90s, because that's really when this engine and the diesel was starting to become popular. There were some gas variants, but most of the gas variants were the Big 40 series. So for a diesel to run, if you have a diesel engine that isn't starting, it's only going to be three things. It's going to be air, compression, fuel. If it's not running, you're missing one of those three things. That's the fire triangle for a diesel. You're missing one of those three things. That's why it's not running. So first thing, obviously the battery was dead, so I put a new battery in it and got it to turn. I actually had to break it free first. So step one, break it free. It was stuck. Lots of WD-40, PB Blast, acetone, gasoline, anything I could shove into cylinders that was a very, very thin oil that was going to help break it free. The starter just did not have enough stuff behind it to turn it over, so I stuck a pry bar in there. And this is the mistake people make, is they try to pry up as hard as they can, and really when you're trying to break an engine free, I like to kind of go both directions. I want to wiggle it. So I have a pry bar here and I wiggle up and down. I go to the other side, I have a pry bar, wiggle up and down. So I'm actually rocking the motor back and forth to wiggle it. And that wiggling motion is what's going to allow my thin oils to get where they need to get to break it free, to get in between those stuck rings and get it to where it's free. And then once I can actually manually turn the engine all the way around once, then I hit the starter. And with a new battery and the starter, it actually got a really good turn going. Now, it still wouldn't start. And there's no puffing coming out the exhaust, like no puffing at all, which means there is no fuel. But I decided to check air filter. Air filter looked brand new. Somebody took care of this before they let it sit. So that's why I have very high hopes for this machine, because it looks like it was very well taken care of before I got my hands on it. Had a brand new oil filter. The oil looked clean, like somebody gave it a oil change before they let it sit. That's very rare. So I cracked these right here. This is where your fuel goes into your injectors, and the fuel gets shot into the cylinder during the compression stroke. So took these right here, loosened them, and turned it, and kept turning the motor. And when you do that, you should see bubbles, and the fuel will start to run down. I also have a leaky injector right there. I need to order new injectors, but I'm cheap. I'm not going to order $40 an injector, and I know that's dirt cheap for a machine like this, but again, I'm a cheap person. So I had no fuel getting to it. So now we get into the function of the machine. How does this machine work exactly? Well, this machine, how do you turn this machine off? If you have no spark, how do you turn this machine off? You shut off the fuel going to it, or the air. It's always, you can control the fuel going off much easier than you can the air. So as you can see right here, this is our injector pump. You can kind of imagine this is our diesel distributor, or if you're familiar with gas engines and how they work, this is basically our distributor, our what do you call it in newer vehicles? Your ignition coil pack, ignition controller, something like that, whatever. For me, it's a distributor. But you have your main fuel come in here. Now, I was able to make sure I had fuel going to here because I disconnected this, and I actually replaced the fuel tank and put another line. This ain't the exact line, but it works because this one, the original one, was leaking really bad, and drained all the water out of the water separator to where I had red diesel coming out the bottom. That's the cool thing about dyed diesel, is it's very easy to find where it's going. And then I made sure I had diesel coming out here, so I knew my catch had to be in the injector pump. So what I did to test that was I took a jumper cable, one here and one here, and then turned it, and sure enough, it fired right up. So at that point, I'm not getting 12 volts to here. Why am I not getting 12 volts to there? What keeps that from working? If you're familiar with the old machines, you know exactly what this is. This is a Murphy switch. It is a safety device, and what it does is it looks for a signal to be dropped. Well, not really a signal to be dropped. It's sending 12 volts through a line to the temperature sensor right here on top of the engine, and then it goes through there and down to here, just your oil pressure sensor. And if either of these engage, these will engage and ground. And when they engage and ground, 12 volts drops drastically. And when that 12 volts drops, this engages and shuts off that 12 volt signal going to the injector pump. So why would it do that? So the reason it was doing it on this one was the temperature sensor on this one was broken and was grounding when it wasn't supposed to. However, it's pretty easy to check. So what I did was I pulled, if I don't trip here, I pulled out the oil pressure sensor and turned it, and oil went flying out just with a couple turns, went flying out the side of the engine. So I was like, okay, so it's not that. Put that back. And then I disconnected, because there are two wires. There's the in and the out. The in coming from the Murphy switch, the out going to the oil pressure switch. Pulled them out, stuck a little small bolt in there, tied the two wires together, and covered it in electrical tape real quick. Then turned, it fired right up. Of course, this is after I replaced the original Murphy switch that was in here, and come to find out I actually didn't have to, so now I have a spare Murphy switch. So I wound up, it's not hard to get that out. I got the other water temperature sensor out of the other Big 50, stuck it in here, hooked it all back up, fired right up. So at that point, that was my problem. I had a faulty water temperature sensor. So now the problem I'm chasing is the fact that this machine will not idle down to save its life. It'll sit there, it has no mode but full run. That's what I'm trying to figure out now. So I replaced the primary switch. The cool thing about this is if the Murphy switch does trigger, it will at least tell you. And then also I had to put a new alternator in there. The original alternator wasn't charging, but it won't tell you that. Even though there's that little light there, it's supposed to tell you that's not charging. It won't tell you. So found that out. When you start this, for whatever reason, I think it's because there's no oil pressure and that sensor will trigger it. You actually have to push this in. This is the front of that Murphy switch there. You see a little button on the Murphy switch. This is the front of it. So you're actually overriding, if I believe, if the theory in my head how this works is correct, you are overriding the Murphy switch to start it. You're basically telling it, ignore the Murphy switch, start anyway, which when you press that in, you're sending power to that injector pump right there, to the solenoid in the injector pump, allowing diesel in. Push it in. Fires right up. All right, guys, so as you saw right there, no 12 volt power is getting to the idle control solenoid. So that means it's most likely power getting to the control board, or the control board is not working. So I can probably jump the solenoid, just go something from the battery positive on the starter over to the solenoid, ground one side, vice versa, just try to do that either way. Figure out, is it one of those? And if one of those makes it engage. If it doesn't, then my solenoid's also bad too. Now the thing that sucks is that's a very expensive solenoid, so I am most likely going to find a cheaper solenoid and slap that in there, because I am a cheap person and I have a machine shop, so I can make anything I want work. And it also looks like somebody did some hobo welding. If I switch this around, almost looks like somebody did some kind of hobo welding right there to put this on. I say hobo welding and I'm the king of it, but right there you can see where we had the voltmeter hooked up, and in both positions, idle full speed and idle down, waited 10 seconds in between each one. The voltmeter never showed 12 volts, either positive 12 volts or negative 12 volts, which means we're not getting power to that solenoid to idle the machine down. Because how this works is the default position of the machine is full speed. So, not full speed, but weld speed, you're high idle. So default position, high idle. That way, if we're in the situation we're in right now, you still have electricity and you still have the ability to weld. And speaking of the ability to weld, once it was running, running's great, but what if it doesn't put out weld power? What do you do next? On these, they're pretty simple. It is a 3-phase machine. So let me explain how this works. You have 3 phases of 110 volts. Therefore, there are 3 armatures right there. I'm probably using the wrong terminology, but bear with me. I'm a little generator ignorant. I'm a little ignorant of the ways of generators, but I know enough to be dangerous. So when I first got this machine, all 3 of those were black. There was no shiny copper whatsoever. They were all black. So first step, the obvious step, is we turn it on. We check for power at the weld terminals right here. No power. Plugged in an angle grinder to the 110, nothing. So I got a brush cleaning stone that I bought from my SA200. I turned it on, and not by hand. I did not stick my hand in there. I took it on a stick. I taped it to a stick and stuck the cleaning stone in here and slowly went back and forth over these until they were all nice and shiny. Once they were shiny, I turned the machine back on, and I had 110 volts at the power outlets and 40 to 75 volts at the weld terminals, and it burns a 7018 real nice. And as you can tell, there's a little rust on it. That was a few days ago, so it does work. It is not impossible to get these running again. It takes a little bit of time, a little bit of thinking, a little bit of pondering, and a little bit of troubleshooting. So let's add this up here. Because I had the parts machine, I was able to get almost all my parts I needed for it from the parts machine, which means whenever I needed parts, I didn't have to spend much of anything. The only thing I spent money on was the alternator right there and the battery down there. And that was all under $200. From O'Reilly's, all under $200. The initial purchase of this machine was I went and fixed a crack in an excavator. Took me about 6 hours. Probably would have charged about $700 to $800 for that. So you can basically say my entire investment in this machine is right at or just under $1,000. This is a big machine to have at a total investment of under $1,000. So out of my pocket, I've only spent maybe $200. Complete investment, including my labor to get the two machines, non-running two machines, is right at about $1,000. So if you were to look at what it would cost to get a brand new machine of this tier and this size with this amperage output, you're looking in the looking 20, 30 plus $1,000. So I definitely made out good, especially with a machine of this size I'm only going to use very seldom. It's really good that I didn't spend a lot of money in it, because this isn't a daily use machine. And that's really nice because it's diesel. It's not a daily use machine. Diesel machines can sit for way longer and fire right back up versus gas machines. Gasoline machines don't like to sit for very long. Things start going bad. Things get, the gasoline goes bad. Stuff gums up in the carburetor. Points in the magneto and points in the distributor start to gum up unless you have electronic ignition, things like that. So for this right here, for my needs, this machine is absolutely perfect, and you can't tell me otherwise. Thank you guys for watching. You guys have a fantastic day.